Hello everyone, James here. Just a quick message before we start this week's episode. I'd like to say a huge thank you to our latest supporters, Morgan and Dee. Thank you for your support of Humanism Now. It really helps us grow the network and reach more people. If you would like to also support the channel, you can join them over at Ko-fi/Humanism Now pod. Links are in the show notes, and we would really appreciate it. But for now, enjoy this week's episode.
Welcome to the Humanism Now podcast. I'm your host, James Hodgson. We often talk here about how humanists have a look at the universe with awe and a sense of wonder, and the value of exploration. Our guest today has not only engaged in that, but has made it his full-time vocation, profession, and now he's helping others to do the same. We're delighted to be joined by Dr Alfredo Carpineti, astrophysicist, science communicator, and co-host of the Big Questions podcast at IFLScience, as well as his own podcast, the Astroholic Explains. Alfredo is the founder and chair of Pride in STEM, creator of the Astroholic, and the author of a forthcoming book, Invisible Rainbows, which explores the unseen universe and the untold stories of the people who reveal it. Dr. Alfredo Carpineti, thank you so much for joining us on Humanism Now.
Thank you for having me. It is such a pleasure.
The pleasure is ours. I know we've been friends for some time now, and I've met you at various Humanist UK events and around in London as well. And I've been a follower of the Astroholic Explained podcast as well, one of the inspirations for us to get started here at Humanism Now. For the uninitiated, what makes someone an astroholic? What first got you involved in the area, and why take it to such an extent?
I think I will have to blame two things. I will have to blame dinosaurs, and I will have to blame London.
Not two things you associate with astronomy.
Not exactly, but that is how my journey started. I was obsessed with dinosaurs when I was a child, like many other children are. It was pre-Jurassic Park, so I always joke that I was into dinosaurs when they were still underground. And every week I would get a little dinosaurs booklet from the newsagents, and it was actually a British publication translated in Italian, and it was by this paleontologist from Cambridge working at the Natural History Museum. And I was obsessed. I wanted to be a paleontologist. With my parents, we decided to come to the UK for holiday, and I was like, we must go to the Natural History Museum, which took some convincing because my parents very much, my dad trained as an architect, my mom loves design. They wanted to go to the Victorian Art Museum, which is a stunning museum, but it is next door to the Natural History Museum. And so I was just like, please, let's go there. And I convinced dad to take me there. And which made him realize that I was never going to be a normal kid, because there was this fossil of a Kelophysis, and it's still there. You can go and see it. But what's really exciting about this fossil is that in the thorax of these small dinosaurs, there is a baby Kelophysis. And so at first they thought that this was the first dinosaurs giving birth to live young. And then they realized it was a little bit too big to be a fetus. And so they thought, at least at the time, and so you need to imagine me as 8 years old, really excited about explaining to my dad that this might be the first cannibal dinosaur. Now we don't think that it was cannibal, that it was just accidental overlay of the fossils of an adult over a juvenile. But at the Natural History Museum at the time, because it was the early 90s, there were a lot of possible explanations for why the dinosaurs went extinct. Because at the time, we didn't know that massive asteroid, the Chickax Club impact, it hurt 66 million years ago. We hadn't found the crater. That was one of the hypotheses. And there were other hypotheses. I remember, maybe if any of you listeners have been to the Natural History Museum at the time, there were little drawings, and one was like that the dinosaurs died of boredom, and there was a drawing of dinosaur playing cricket. I didn't get that joke at the time. We don't have cricket in Italy, at least not diffuse enough for 8-year-old to get that joke, but I'm sure that it was very popular in the UK. But another possible explanation was a supernova. And I had no idea what that was. Dad didn't know what that was. When we went back home, looked up on encyclopedia, and I found this explanation, but it was very technical. The next thing I asked was a book about astronomy to better understand. And then I asked for a telescope for my Holy Communion. The Catholicism coming in with that. And then the rest is pretty much history, because when we finally set up the telescope, I was just like, it just came natural. Like, I pointed at something in the sky, like, that is Jupiter, let's look at Jupiter. And I was like, how can you know that it's Jupiter? And it's like, not twinkling. It's not twinkling, must be a planet, and it's so bright, and it's late at night, so it cannot be Venus. It must be Jupiter. And we looked at it, and we saw the band, and we saw the great red spot, and suddenly it was just like, everything clicked in my brain. And that was 30 years ago. And I knew that I wanted to do astronomy. I knew that I wanted to study and understand the universe. So I think, to summarize and actually give you a proper answer, what makes an astroholic? I think somebody that just have such a passion, borderline obsession with finding out what's out there in the universe.
And what keeps you curious and passionate about the cosmos today? Have you maintained that childhood excitement and wonder that you had when you were 8 years old?
Oh, absolutely. And it's the fact that first of all, we know so much now. We have learned so much. But if then we can break it down in any kind of historical period. We can start it with the start of modern Western science, Galileo onwards, and was like, oh my God, leap and bounds. We can consider the last 100 years when we understood that our galaxy is just one of, now we assume at least 200 billions in the visible universe. Or we can just say, how about in the last few decades? How about in the last decade? And there's always like these leaps and bounds. And what really excites me is the fact that we can consider so many things that now we understand, and just tells us how much we do not understand. There are so many things that we have a good understanding. We understand, for example, how a star is born, how it evolves, and how it dies. We have a broad understanding of all those steps. We do not have a detailed understanding of those steps. Yes, we understand that some stars become supernova, and we have a good mass range of which stars could become supernova. We know the sun will never end up being a supernova. But the details of how the star will evolve into a red giant and eventually a white dwarf, or when massive stars like Betelgeuse will go and explode, is still beyond us. We do not have enough knowledge yet. And this is what's exciting. It's a process. Is the fact that every day I wake up, I go to work and read some of the latest science news and some latest science research, and try to turn it into news and make people excited about that. And there's always something new. And this is wonderful. It's every day is Christmas.
Yes. And but I guess with each of those new announcements, this is a whole career's worth of work that's gone into making these small steps. And
yeah, it's like there are people that have, and to be honest, I have a PhD, so I have really specialized knowledge. It's some things that for a period I was the world expert, but it's a tiny fraction of all of the human knowledge. And so seeing people working on something specific that might seem so niche, but what I do as a science communicator is then connected to the wider picture, the importance of it. It's for me, science is partly for the sake of science, for our quest to understanding the universe and wanting to know more, but it's also because it makes, in a way, enriches our lives. I truly believe I truly bought into Carl Sagan's where the universe knowing itself. It's not because the universe has a consciousness or anything, but is because we are here and we can comprehend this extraordinary universe. We are apes that evolved to probably scavenge in the savannah, and we're here like with the ability to do amazing things, and we should be doing those amazing things.
It's very inspiring. And I'm fascinated by the role of the science communicator. As you said, you've got you're highly trained in a very specialist area, your area of astrophysics, but I guess in your day job, you're reading in a much broader field and then communicating that to the public and making that accessible, which is a very difficult and very important step. So how do you strike the balance between staying true to the difficult, granular science and I guess the expert level of the intricacies of the discoveries versus telling a compelling narrative story that gets people hooked and engaged in the same way that you were as a child? Do you have to take some liberties with the science in order to make it compelling? And I'm always curious how you strike that balance.
That is an excellent question. I think it's not exactly about taking liberty with the science. We often need to simplify things. It's important to simplify things because you want to get the people on board. You can do analogies. The problem is we shouldn't consider that the simplification or the analogy is the be-all and end-all. I think, especially in this day and age, with so much misinformation going around, that stressing the limitation of science, the caveats, can be, sometimes is just as important as the results. And I think people do love complexity and can follow along with the complexity and understand it as long as you explain why it is important to discuss the complexity and once again the limitation, etc. During the pandemic and not so much lately, but I've been writing a lot about medicine. I accidentally found myself for most of 2020 as being the sort of COVID reporter for IFLScience, simply because it all started between Christmas and New Year 2019, and is usually the period where there are no news. And I spotted somebody on Twitter at the time that was talking about this weird fever happening in Wuhan, and we didn't have any news. I was like, oh, we can cover that. Even at the time we thought it was going to be a bit niche. But the scientist was like, I was hoping there would not be something like SARS or MERS. And so start writing about it. 5 days later, the World Health Organization declares an epidemic. I've been the person that I've written 3 articles. A month later, I'm the person that I've been following from the beginning. So I've been doing a lot of medicine. And when it comes to medicine, especially in new research, especially research that can bring hope to people, like potential new treatments, is you need to be extremely clear about, for example, and this has been only tested in animals. This is a clinical trial. What kind of level of clinical trial? What is potential side effect that's seen, etc. It's less so when it comes to astronomy. If researchers are pretty convinced that something is a planet and not a brown dwarf, it's nobody's going to die or nobody gonna get their hopes up if it turns out the other way around. So when it comes to stuff like medicine, you need the limitation or part of the story. And I think, and at least I feel that helped me put the limitation as being part of the stories, even when it comes to astronomy. A good example that I do talk about in the book, I talk about when I give talks, is this fantastic gas cloud at the center of our galaxy, the Milky Way, and has this interesting molecule that is called ethyl formate, which you probably think, like, I never heard of this molecule. But I will tell you that you have probably smelled it and you probably taste it. Maybe not taste it, not all of you, but smell is quite a good bet because it's responsible for the smell of rum and the taste of raspberry. And it is interesting that there is this molecule in a cloud in the Milky Way that has this property. And I just, ethyl formate, that's interesting. But what's the next step is usually people start thinking, oh, okay, so there's this cloud that smell of rum, taste of raspberry, etc. And it's good to stress to immediately break that notion, to say, no, that is not exactly like this, and has an extra level of science that you add to it. First of all, you explain that the cloud is mostly made of hydrogen. But hydrogen has no smell, so it's not that interesting. And they probably wouldn't care. But my punchline whenever I do this kind of talk is point out that the fragrant molecule, a molecule that I work out that is probably the most common that has some sort of smell, is hydrogen cyanide. So you could sort of argue that's probably smell like bitter almond, and usually that gets a few laughs. Especially, I tend to do sometimes cocktails when I give this explanation. So I said, "Don't worry, I'm not pulling Agatha Christie on you. There is no cyanide in the drink, etc." But what's interesting is then pointing out that why there is cyanide, why there is this ethyl formate, why there are all these other molecules in these clouds that are found in life on Earth. And it's because building blocks of life on Earth are found everywhere in space. And that is just like a cloud in the middle of the Milky Way. It's not like we found stuff that is precursor to RNA and proteins in comets and meteorites and asteroids, but finding just in a random cloud, it tells us that the building blocks of what it is, then the building blocks of life, are everywhere. So that make us think that maybe life in the universe is not as rare as we currently perceive, being the only known intelligent species.
That's fascinating. Yeah. And I got a sense there just of how you can bring people into the story. Yes, you share the technical terms, but bring them in with things which we might all recognize, and that becomes the hook then to then say, but why is this important? And bringing that back, getting people engaged and then explaining why it's important. I can see how that has a much stronger effect. And thank you also for bringing us round to your book, Invisible Rainbows, which there was a fantastic preview of at the Humanists UK convention last year. So the book has a double meaning, doesn't it? So I'd like to talk about each of those elements in turn. But if we start off with thinking about looking at the universe, what is it that we miss when we look up at the night sky?
We are able to see the universe in just a fraction of all the light that exists. The electromagnetic spectrum is so much wider than our senses allow us to experience. And once that has been incorporated into astronomy, because there was a lot of pushback from traditional astronomers about using radio waves and infrared to study the universe, they really taught in the 60s is no, astronomy is what we can see with our optical telescopes, like we were looking with our eyes, plus lenses. Everything else, no, that's physics, it's not astronomy. But we started finding things that we wouldn't have discovered otherwise. A great example from the 60s was the discovery of pulsars. These are extreme stars that pulsate some of them hundreds of times every second. X-ray telescopes in space, X-rays and gamma rays telescopes sent in space to monitor nuclear testing, actually discover events beyond Earth. And there were explosions of incredible magnitudes. And in history, we haven't seen one in a while to the naked eye, but there's been supernovae. And suddenly we were seeing this flashing all over the place thanks to telescopes that are placed in space. And so for me, when I started thinking about a topic for a book, I thought it would be fascinating to talk about the latest news about how we use this unseen light to understand the universe. Everything that we miss, everything that we still don't know, and why it is fundamental to use all the light, why it's fundamental to consider things in a very holistic way when it comes to the universe. Sure, there are events that are predominant in one type of light, but there are so many that exist across the spectrum, and looking at the different parts of the spectrum paints at least a more complete picture. And as I mentioned, there's so much that we don't know, so we do need those kind of interlocking pieces to unlock a better understanding of these events. A classic example is supermassive black holes, because they're usually studied in radio waves, because they emit in radio waves, and they're studied in X-rays, which are almost at the opposite end of the spectrum. And clearly there is an overlay across the wavelengths of that, but those are where they emit the most. And those two extremes are very important to understand how supermassive black holes work. The sun, we tend to study it in wavelength. Obviously, we studied invisible light because it's so easy from Earth. When the light passes through the atmosphere, we have loads of telescopes and everything. But we put telescopes in space to study the sun in ultraviolet, because that allows us to penetrate the surface layers of the sun and see what's happening right beneath the surface. And it's very important, because those kind of observation help us protect the planet from solar storms and other changes in the sun activity. So it's both for our safety and our knowledge that we need to study the universe and study what's around us in light beyond the visible.
And you shared some of the images during that presentation as well, so that the accompanying photographs that go with this is quite breathtaking when you can see what is invisible to the naked eye, but once you see what everything that's out there, is quite miraculous.
There are some images that are literally, I am somebody that is lucky enough to spend many days just looking at a pretty picture of the universe. And I am still so in awe that some of the latest telescopes can do absolutely incredible imaging of the universe. And I have sometimes people telling me, oh, but does the universe really look like that? Or does that nebula really look like that? And I'm like, not to the naked eye, but that doesn't matter to me, because I am unfortunately not on the bridge of the Enterprise. I am not going to go to, I don't know, the Orion Nebula and see it with my naked eye. I'm here on Earth, and I can be, just say, I'm here stuck on Earth. But we have observatory like Hubble, JWST, or the very large telescope looking at the nebula and seeing incredible details. And it doesn't matter that the telescopes are not mimicking the human eye. Even all the optical telescopes have filters, some to a non-specific wavelengths, some to just make the picture prettier. What's exciting is what we're seeing. It doesn't matter that, I don't know, the Juno spacecraft on Jupiter has all these enhanced views of Jupiter that showcase the turbulent atmosphere. Yeah, it doesn't matter. That's not what Jupiter would look like up close to the naked eye. We are seeing the the massive hurricanes that pass through the atmosphere of the biggest planet in the solar system. That is exciting. The fact that Cassini could see a storm in the North Pole of Saturn, that's exciting. It doesn't really matter that, is that exactly the color that you would see if you had a spacecraft there. And if you're really against enhanced images, I would say let's work together to get a spacecraft with humans there. And let's go and take those pictures, or let's go and take those tours and see the difference.
Oh, you can really sense the excitement that this still brings to you, and it's wonderful, Alfredo. And it really came across, as I said, in the talk and in the book. So let's talk about the other side of the meaning as well. I know you wanted to also draw attention to the human stories behind a lot of these discoveries, and some of those which were not, had been untold or perhaps hidden until this time. So why was that important to you?
When I first started thinking about the book, I was reading a lot of other books about science. Also about astronomy. I wanted to be inspired by the greatest, by people that I respect in the community, and even in the books that I found that were like the best, I started recognizing a lot of names. And of course, I would recognize the names because I am somebody that has been in the field for now decades. So it's normal that I say, oh, I recognize that name. I was a collaborator, or I've read a paper, or I saw them speaking at a seminar or at a conference, etc. And in my head, I was like, okay, one can use a book to provide a platform, but also a pedestal for scientists to talk about the research. And a lot of the books that I had read had a very specific goal in what kind of subjects they were talking about. So a lot of the people that had been interviewed for them had, they were the luminaries. They are the people with the professorships, and there were people that were famous in the field for that work. Given that my focus was about the wavelengths, I had a lot more liberty in picking and choosing who I wanted to highlight. There is in no place of the book that I say, oh, this is an exhaustive chapter on everything you need to know, I don't know, about infrared. No, it's a tasting menu. You jump in and find something that is interesting, and that's it. And that allowed me to be more free in who I selected to be in the book. And that was by choice, because I thought my title is Invisible Rainbows, because there are rainbows in the universe that are invisible to our eyes, but they exist across other wavelengths. And like, I would be missing a trick if I wouldn't be using the book to provide a platform for LGBTQI plus astronomers to talk about their work. With Pride in STEM, most of the last decade I've been working to raise the profile and to showcase and support LGBTQI plus people in science, technology, engineering, maths. I thought this is probably my one and only chance to write a book. I will try to also give an opportunity to a lot of other people to talk about their work. And it has been an absolute honor to feature almost 2 dozen people across the wavelength and across the area of expertise, across career levels. There are people that when I started writing, they were doing their PhDs, and there are professors in it, trying to be as inclusive as possible and have people from every continent. Obviously, there is a bias for Europe and North America, simply because you need people that are comfortable being interviewed in English, that I was able to reach. They are comfortable being recognized. I don't get too much details into their personal stories because I wanted them to talk about their science and be recognized as expert, but also it's clear that they are part of a big LGBTQ book, or as one of my friends described it, the big book of queer astronomy. So with all this in mind, it was, there are obviously limitations created, but this selection of people, but they felt that this was something very important that I needed to make happen, given space for them to give long and comprehensive answers, and I'm the one then explaining things around and adding the details, and they can just shine as the experts in the field that they are.
Well, it's wonderful to use the platform your platform that you've worked so hard for to also share and elevate other voices as well. It's a fantastic book. The talk, which I think is available to view, if it is, we'll link to it in the show notes, from the Humanist UK conference, was a real highlight as well. We look forward to what's next, and I guess what is next for you? What are you working on now, and what will be your next project?
The book should be out with Walton Square Books in May 2021. Hopefully by the time that this podcast is out, we will have a pre-order link. It should be any day now from the point of when we're recording. And yes, that is the current project for the book side, for Invisible Rainbows. I am writing a little proposal for a second book. I'm feeling optimistic, but to be honest, it's been a long journey for Invisible Rainbows. So the question is, let's get one out and then work on the second one. But I hope it comes across that I like to be busy and I like to have projects. And so that is the current personal journey. I am working still at IFLScience. Things are going very well there. I'm very happy. And when it comes to Pride in STEM, we're going to celebrate our 10th anniversary in April. And we are very excited for a few more projects happening this year. And we'll continue to support LGBTQI plus people in STEM going forward.
Oh, congratulations on your 10 years with the group. That's wonderful. And I know you're coming to give a talk to the London Humanists as well.
Yes, I was going to go with because that is not the only humanist talk that I'm giving soon. Yes, is going to be a talk about space, but also about fiction. And we will be talking about how humanism relates to both astronomy and science fiction. It's going to start with a few, I'd say, not too controversial, but I would like to argue that the big question that we often ask or consider as realm of astronomy are questions that are shared across philosophy, across religions, etc. The difference is that astronomy can provide some factual answer to them. And I think that is what attracted me to the field and what people that are humanists can find interesting when it comes to the connection between science and those big queries. And obviously, a lot of science fiction has humanist element or strong humanist angles. And a lot of science fiction focus on space and the exploration of space, or at least space travel. So we thought it would be fun to talk about something that was very realistic and then explore how the fictional part of that uses elements or completely turn some of the elements upside down to discuss very much what is the human condition, what is humanism, how do we relate about being humans when we discover aliens or we build androids or we meet entities out there that for all intents and purposes would be recognized as gods by earlier human civilization and stuff like that. And I think it's fascinating. It's very rare to find a scientist that has not an interest in science fiction. And it's always nice to talk to big science fiction fans because they have a lot of questions about science. And so I am very happy to sit at the nexus between the two. And that is going to be on January 28th in central London and also online. And then on February 12th, I am in Manchester for the Darwin Day lecture with the Greater Manchester Humanists, and it's going to be about life and light. As you have heard, that I am quite a big fan of light, and we're going to discuss how that helps shape life, both on Earth at a very intrinsic and quantum mechanical level, because one of my degrees is theoretical physics, but also discussing how, as you heard, light plays a massive role in creating those building blocks in space that eventually came and formed us here on Earth.
Thank you. We're looking forward to both of those. Speaking of the big questions, you mentioned how science can answer many of these questions. One thing I like to ask scientists that we have on the show is if there was one outstanding question that you would like to know that we discover the answer to during your career, which one would you choose?
If there are other intelligent civilization in our galaxy, there are more important, scientifically, there are more important questions. I think trying to understand how the whole of physics fit together, the grand unified theory, would be fundamental. But I am extremely optimistic about that. I feel that while it's going to be difficult, we'll have to build bigger detectors, come up with more clever ways to study the universe. I feel optimistic that we can find answers in the coming decades. But I feel that the universe is big and our galaxy is tiny in the universe, but enormous for us. And I think that we might be able to find life elsewhere in the universe, or at least evidence of life in the coming decades. But most likely it's going to be bacteria stuff or something that is not us. And I would love to know if there is somewhere else in the universe people that are looking up at the heavens asking the same question. Are we alone? I would love to have that answer. I don't know, a genie, God, to just call upon one answer. Everything else I'm happy to research. But that one I would love to know.
And finally, our standard closing question. What is something which you've changed your mind on recently and what inspired that change?
Okay, I have decided to be quite controversial for this answer because it's something that is hotly debated by Humanists UK, especially. So I want to start by clarifying things. I have always been a fervent, borderline militant supporter of the right to die and euthanasia, and being able to choose a dignified death if that is your choice. And it's always been like that because I remember two particular cases in Italy in 2006 and 2000 and in the early 2000s. And one was this poet and activist called Pier Giorgio Welby, who refused feeding to have the right to die after living with multiple sclerosis for decades. It remains so impressed to me that because of that choice, the Catholic Church mounted a campaign against him and refused for him to have a religious funeral.
Mm.
And the reason he died on the 20th of December 2006. And the thing that remained most impressed to me around those weeks was that it was a week and a bit after the death of Chilean dictator Augusto Pinochet, who got a religious funeral. And it was very clear to me that, oh yes, you can kill tens of thousands and the church will welcome you with open arms, but you make a decision about how you want to live your life. And oh, you're out. Yeah. And that was even beyond. Like, as a young queer man, I felt very much the oppressive hand of the church on the Italian government, more in the situation of Ilona Englaro, a woman that was in a coma, in a irreversible coma since 1992. And the church didn't try to stop the government to pull the plug. And she eventually passed away in 2009. And one thing that I did, and I had just moved to the UK, was to have a living will to make sure that people knew that I didn't want to live attached to a machine. I would rather my organs be given to other people. And there's a lot of things. That was a long preface to get to the point that I want to make on slightly changing my mind. I have not changed my mind in thinking that we shouldn't have that right. I'm still very much on board with that. But I think that we need to have a more nuanced discussion when it comes to the concept of assisted dying, when it comes to points raised by disability activists. I absolutely disagree with the many, especially now in the House of Lords, points raised by religious people about the sacred life. I do not think they'd care about life being sacred, because otherwise they would be the first one to protest genocides and selling weapons, and the fact that in this country we have so many people that cannot afford a hot meal or don't have a house. If they truly believe that life was sacred, they should be protesting that, not assisted dying. But the points raised by disability activists that before you can have a dignitous death, you should have a dignitous life, that there should be accessibility, there should be a better society in general, I completely and 100% agree. And I feel that as humanists and with our belief that we need to act for everyone, need to consistently raise that point. That I used to remember how militant I was about, no, we need to get this, we need to get this, we need to get this. And now I want to say we need to have a good debate. We don't have to discount people that they disagree because they have concern about how that might be used. And so I am taking a more, let's say, relaxed approach, a more open approach. I feel that we need to continue to have a debate, and we need to bring in people that disagree, not because they think this shouldn't be a right, but because they think could there be unexpected consequences. So yes.
Oh, very well said. And Dr. Alfredo Carpineti, thank you so much for joining us on Humanism Now.
Thank you very much for having me.
Thanks for listening to Humanism Now. If you like the show, please leave us a review. It helps more people find us. Support us from just £5 a month for exclusive content and to shape future episodes, and we'll plant a tree each month in your name. Follow us on all socials at Humanism Now Pod, and help spread curiosity, compassion, and human progress. Humanism Now is produced by Humanize Live, creating world-class podcasts, videos, and events for purpose-led individuals and organizations. Learn more at humanize.live.